In today's video, we are going to start it with ATtiny85 microcontroller. The ATtiny85 is small, low-cost microcontroller that is perfect for simple electronic projects, where we don't need all the features and pins of a larger Arduino board. In this beginner-friendly tutorial, I will show you step by step how to program the ATtiny85 using the Arduino IDE. And as our first project, we will create the classic LED blinking project. By the end of this video, you will know how to set up the ATtiny85 in Arduino IDE. Connect it to a programmer, upload a program, and control in LED. So let's get started. Before we start, let's take a quick look at the component we need. In ATtiny85 microcontroller, Arduino board that we can use as a programmer, 10 microfarad capacitor, LED module, breadboard, and some jumper wires. The ATtiny85 is small low-cost 8-bit AVR microcontroller from Microchip. It is commonly used in compact electronic projects because of its small size and low power requirements. The ATtiny85 provides 8 KB of flash memory, 512 bytes of SRAM, and 512 bytes of EEPROM, along with the digital I/O analog to digital conversion, PWM, timers, SPI and I2C compatible communication. The commonly used DIP portion has 8 physical pins, of which 6 can be used as a programmable input-output pins, while the other 2 are dedicated to power and ground. Starting from pin 1, it is PB5, which can function as a digital I/O pin or reset. Pin 2 is PB3, which can be used as a digital I/O pin, ADC3. Pin 3 is PB4, providing digital I/O, ADC2. Pin 4 is ground, which is connected to the ground of the power supply and circuit. Pin 5 is PB0, one of the most commonly used pin, and it can function as a digital I/O, MOSI for SPI and SDA for two-wire communication, as well as supporting PWM and other alternative functions. Pin 6 is PB1, which provide a digital I/O, MISO for SPI and PWM functionality. Pin 7 is PB2, which can be used as digital I/O, ADC1, SCK for SPI and SCL for two-wire communication, and an external interrupt. Finally, pin 8 is VCC, which is the positive power supply connection for the ATtiny85. Before we start programming the ATtiny85, let's take a quick look at how this tiny microcontroller compares with some of the other popular microcontrollers that we commonly use in electronic projects. Here I have the ATtiny85, Arduino UNO, ESP32, and XIAO ESP32-C3. As you can see, the ATtiny85 is much smaller and has a far fewer pins and resources compared with other development boards. The Arduino UNO is also an 8-bit AVR based microcontroller, but it provides more memory, more I/O pins, and is much easier to use for larger beginner projects. Moving to, we have the ESP32, which provides considerably more processing power, memory, and wireless capabilities, making it suitable for more advanced projects. Then we have ESP8266. We get a much more powerful 32-bit microcontroller with built-in Wi-Fi, making it suitable for IoT and internet connected projects. And finally, we have the XIAO ESP32-C3. Is also extremely small, but unlike the ATtiny85, it gives us a 32-bit RISC-V processor along with Wi-Fi and Bluetooth Low Energy. So compared with these boards, the ATtiny85 is definitely not the most powerful. But that's not really its purpose. The biggest advantage of the ATtiny85 are its small size, simplicity, low resource requirements, and suitability for simple standalone projects. If all we need is to read a sensor, control an LED, operate a button, or perform a simple control task, we do not always need a powerful ESP32 or a complete Arduino board. And that's where the ATtiny85 become very useful. So in this video, we are going to take this tiny microcontroller and see how easy it is to program it using the Arduino IDE. Before we burn the bootloader and configure the ATtiny85, we need to make the correct connection between the ATtiny85 and the Arduino UNO. First, connect pin 1 of the ATtiny85, which is the reset pin, to pin 10 of the Arduino UNO, which is used as a slave select pin. Next, connect pin 4 of the ATtiny85, which is ground, to the ground pin of the Arduino. Now connect pin 5 of the ATtiny85, which is MOSI, to pin 11 of the Arduino, which is the Arduino MOSI. Then connect pin 6 of the ATtiny85, which is MISO, to pin 12 of the Arduino. Next, connect pin 7 of the ATtiny85, which is SCK, to pin 13 of the Arduino. Finally, connect pin 8 of the ATtiny85, which is VCC, to the 5V pin of the Arduino UNO. There is one more important connection we need to make on the Arduino UNO. Connect a 10 microfarad electrolytic capacitor between the reset and ground pin of the Arduino. Make sure the positive leg of the capacitor is connected to reset and negative leg is connected to ground. This capacitor helps prevent the Arduino from automatically resetting while it is being used as an ISP programmer. So these are all connections we need between the Arduino UNO and the ATtiny85. Before moving to the next step, carefully check each connection to make sure everything is wired correctly. Now let's prepare the Arduino IDE so that it can recognize and program the ATtiny85. Go to File, then select Preferences. In the Preferences window, you will find the Additional Boards Manager URL field. Copy the ATtiny85 board package URL and paste it into the field. As you can see, I have already pasted the URL. After pasting the URL, click OK to save the setting. This will allow the Arduino IDE to access the ATtiny board package, which we will install in the next step. Next, go to Tools and open the Board Manager. In the Board Manager window, select the Contributed section. Here you can find the ATtiny board package that we added earlier. As you can see, I have already installed the board package, so it is showing as installed. If you have not installed it yet, you will see an Install button next to the package. Simply click Install and wait for the installation to complete. Once the installation is finished, the Arduino IDE will be ready to work with the ATtiny85. Now we need to configure the ATtiny85 in the Arduino IDE. First, go to File, Examples, Arduino ISP, and open the Arduino ISP example. Upload this sketch to your Arduino board so that it can work as an ISP programmer for the ATtiny85. Go to Tools, Board, and select the ATtiny85 board. In the Processor option, select ATtiny85. Next, set the clock to internal 800 MHz. Then under the programmer option, select Arduino as ISP. Once all these settings are selected, the final step is to click Burn Bootloader. The Arduino IDE will now configure the ATtiny85 according to the selected clock settings. This is a one-time setup step for the particular ATtiny85 and clock configuration. So you normally don't need to repeat it every time you upload a new program. However, if you change the clock or other fuse related setting, you may need to use Burn Bootloader again. Now let's upload our first program to the ATtiny85. We will use the built-in blink example from the Arduino IDE. In the code, you will see the LED built-in. Since we are using an external LED instead of a built-in LED, we need to change this to 0, which corresponds to the ATtiny85 PB0 pin with our selected pin mapping. After making this change, make sure the correct ATtiny85 board processor, clock and programming setting are still selected. Finally, click Upload using Programmer to upload the Blink program to the ATtiny85. Once the upload is completed successfully, we can connect our external LED to select pin and test the circuit. Now let's connect the LED for our Blink test. Since we have select PB0, which is physical pin 5 of the ATtiny85, connect the G pin of the LED module to pin 5 of the ATtiny85. Then connect the ground pin of the LED module to the ground of the circuit. Now let's test our project. Power up the circuit and see the result. And there we go. The LED is blinking perfectly. This means our ATtiny85 has been successfully programmed and our blink program is running correctly. As you can see, even though the ATtiny85 is a very small microcontroller, we can program it using the Arduino IDE and use it just like a small standalone controller for simple electronic projects. And that's it for this ATtiny85 Getting Started tutorial. If you found this tutorial helpful, don't forget to like the video, subscribe to the channel and turn on the notification bell for more electronics and microcontroller projects. Thanks for watching and I will see you in the next video.